Hi everyone, welcome to our webinar. Thank you for attending, and we will do introductions, and please do participate, please ask questions. We will take all the questions at the end of the webinar rather than throughout the session. So if you have any questions as we go along, you can pop them in the chat and we will answer them as we go along.
Okay, get the slides to move forward. Here we are. Okay, hi everyone. So my name is Rachel Neal. My picture's there on the left-hand side, but hopefully you can also see me in the corner of your screen as well. Just to echo what Anya said, thank you very much for coming along today. We hope that you find the next hour, or maybe just shy of an hour, interesting while we talk about bioveterinary sciences at the University of Reading. And joining me today are two colleagues, Dr. Caroline Reimer, perhaps you can give a wave, Caroline, who works with me on this programme. We're both the programme directors for the course, so we kind of manage and oversee the course. And then also Dr. Zoe Barker, who is one of our lecturers and researchers in the area of bioveterinary sciences. So we are all representatives of the Department of Animal Sciences, which is based within the School of Agriculture Policy and Development in the Agriculture building here at Reading, which is on our White Knights campus. We're also lucky to have university farms nearby, including one which we'll probably reference as Cedar if we talk about it during the course the next few minutes, which is very close by as well, just south of the M4 motorway here near Reading. And at Cedar we have a range of animals, including over 450 dairy cows and their calves. We also have some pigs, and we have poultry, and we even have some llamas as well. And we're really proud to be ranked 6th in the UK for animal science according to the Times and Sunday Times Good University Guide this year, which places us in a very good position to be offering our bioveterinary sciences degree, which, as the name suggests, is very animal focused. The three variants of the bioveterinary sciences course that we offer here at Reading, the first one there is the 3-year BSc Honours Bioveterinary Science. We also have a 4-year version of that course, which includes a placement year. So you do 3 years full-time at Reading plus a placement year in industry to get some work experience. And we also offer bioveterinary sciences with foundation as well. And some of you have probably joined us today because you're interested in understanding more about what bioveterinary sciences is as a degree subject, and hopefully this will give you a taster of that. One thing we do know is that every university that offers bioveterinary science has a slightly different take on it and a slightly different curriculum. But at Reading, we approach this subject area quite holistically. So we approach animal health and welfare holistically, believing that it's a really good idea for you to have an understanding of all the factors that underpin, all the science that underpins how animals work and how we as animals, we as humans even interact with those animals. And on the screen here, there are some different subject areas that we incorporate into our degree. And Caroline and Zoe are going to pick out a couple of those and give you a small taster of those areas today. But we think about animal biology and biochemistry, thinking about cells and even molecular basis of how animals work. We think about disease and disease management and how we manage animal health, both thinking about infectious diseases and even non-infectious disease as well. We think about the effect of the environment on the animal, and indeed the animal on the environment sometimes. We also think about the scientific study of animal behaviour and welfare and ethics, which Zoe is going to talk to you a little bit more about. We think about human-animal relationships, so thinking about all the different ways that society works with and perhaps utilises animals in different aspects of life, such as in farming and sport, companionship and leisure. We also think quite a lot about animal nutrition, thinking about what the animal requires and how we manage their nutritional needs to ensure optimal health and productivity as well. So I'm going to hand over to Zoe first. So we're going to hear from Zoe and Caroline for the rest of this session, and Zoe's going to start off by talking to you about animal welfare science, using some examples of how we might think about pain as an indicator of welfare. So over to you, Zoe, and please do tell me when you'd like me to move your slides on. Okay.
Yeah, sure. Thank you. Yeah, thank you. I just echo Rachel's welcome. So we're going to go straight in there, and in a little minute I'm going to tell you a little bit more about kind of what animal welfare science is, but I'm going to start off by showing you a video and asking you to have a look at it. So this video is of 2 lambs. You can see there quite a bold 22 blue on there. The other lamb that you can't see as well the markings of at the moment is our red lamb. So hopefully you can pick those out. So the standing up lamb is blue. The lying down lamb is the red one. You can see the markers on there now a little bit more. So red F, blue F. So these lambs have undergone a procedure called tail docking. This is something that farmers do to try and make sure that lambs don't get fecal matter stuck around their tail, because they can get sort of messy around their bottoms. And if they do that, then flies can land on it and lay their eggs on it. And then we get this nasty condition called fly strike, where maggots start to grow around the fleece, and it's particularly unpleasant for the sheep. So historically, we've managed that by removing their tails at an early age. So these lambs are under 1 week old. And I'd like to ask you to vote in a little moment for which lamb you think has received local anaesthetic. So this could be one potential way in which we could reduce pain. So one of these lambs has had local anaesthetic, one of them hasn't. Give you a little moment longer on the video, and then I think if we move on to the poll, maybe about 10, 20 seconds, something like that. Hopefully that's given you enough time to see. Okay, so a quick vote for you. If you think the blue lamb received the local anaesthetic, then vote A. And if you think the red lamb received the local anaesthetic, then vote B.
So we're just getting the votes in. And I'm giving you 10 more seconds. So if you haven't yet, please cast your vote so we can announce the result. So everyone's done their vote, and everyone voted 100% for red.
Okay, well done. Right, so you're absolutely right. So I'm going to ask you if you wouldn't mind writing in the chat, was there anything in particular that made you think that it was the oh, sorry, hang on, you've all said red. Ooh. Oh, maybe you've not understood the question. So it was which lamb received the local anaesthetic. So I wonder if that changes the vote. So the lamb that received the local anaesthetic is the one that is feeling less pain. And that's actually the blue lamb. It's showing less pain symptoms. So we can see our little red lamb there. If Rachel, if you don't mind keeping the video going for a moment longer, that'd be great. So we've got a head tuck there. We've got kind of sort of reaching around and trying to have a feel at our back end. The red lamb's a little bit wobbly. You can see it sort of falling over and lifting its legs. So its rear end is painful. The only real sort of pain sign we've got from our blue lamb was a little moment ago. It did a bit of a tail shake. So this is one way in which we can use animal science. Okay, so we can start to use, this is what animal scientists do. They tend to do it in a slightly more objective way. So we'll set out what we call an animal behavioural ethogram, and we'll spend some time observing a predetermined set of behaviours. And then we can compare one group with another that have maybe had a different treatment applied, or that they've undergone some different experience to the other group. I'm going to show you some photos now, so maybe we'll move on to the photos and give you another little test. So these are 2 cats. One of these cats would benefit from pain relief. which one do you think would benefit from pain relief? Would it be A or B?
Oh, 50% of people voted, so if we give you 10 more seconds, if you can please cast your vote. Everyone voted now. So we have 75% for cat A and 25% for cat B.
Okay. So what I'm going to ask then is if you could write in the chat, why did you vote for the cat that you voted for? What made you think that cat would benefit for some pain relief? You can test our panel as well at the same time if you have any opinions. Okay, right. It's interesting. So we've got things about the face tilt and the lack of eye contact. So what you've and what I should say is for those of you who said cat A, that was the right answer. So yeah, you've observed some of the things that we have started to use as animal scientists to look at pain in different animals. So you've looked at the eyes and you've looked at the facial expressions. If we move to the next slide. What you've inadvertently done just then is use something called a grimace scale to choose what you're doing. So this is a set of scales that were developed first of all for lab animals to help determine whether they were experiencing too much pain and whether we should change or stop what procedures we're doing with them. And it uses different parts of the face to work out if the animal's pain. So we have the eyes, so we have orbital tightening, so you can see that squeezing of the eye on the rabbit picture. And there's also things like a sort of tightening of the jaw muscles, the nostril shape, whiskers sort of being pointed downwards. So that cat had definitely got orbital tightening, it got downturned whiskers. So yeah, well done. You've basically used the grimace scale for a cat to identify that it needed some pain relief. So we use our understanding of animals in lots of different ways, ultimately to try and improve their health and welfare, because we have the responsibility for keeping animals in different settings. So we've got lab animals, we've got farm animals, and we've got pets as well, and zoo animals. So if we pop to the next slide. An animal scientist way back when, the sort of starts of animal welfare science was in the late 70s, early 80s, when this framework here was developed. This is the 5 Freedoms framework. So some of you may have heard of it. And it stood us very well. It's simple but easy to understand. So we want our animals to be free from the first 4 things, so hunger, fear, discomfort, pain, distress, and also to be able to express normal behaviour. When this framework was developed, our animals were in a very different place, especially our livestock species. We had a number of species that were actually confined quite tightly. So some animal species, pigs and calves, were unable to turn around. So back then, the ability to express normal behaviour was actually, can they just move? That was normal behaviour. Now, these freedoms still kind of work, but what we know and understand about what the animals is much further, because our science has developed in terms of what we know about what animals need. And we've developed another framework, if Rachel can move on, and that's called the 5 Domains framework. And that has lots of the same things as the 5 Freedoms. So the nutrition, the environment, the health, and the behaviour are all still there. But what we do is emphasize a little bit more the mental state, the affective state of the animal. And we're always looking for really good ways in which we can assess and observe animals and to judge their environment and also the animal themselves and their mental state. So we have all these different, if you come and study with us and do the animal welfare modules, you'll learn about the different assessment methods that we use for determining whether an animal is in a good welfare position. And if you carry on, there's a little extra bit there. So this framework and this moving towards the paper that's title is there from 2016 by David Mellor goes on to sort of suggest that we should be moving away from these five freedoms and towards a life worth living. And by life worth living, what he's trying to suggest is that we need to give credence to increasing the number of positive experiences and not just reducing negative ones. And that is what we call positive welfare. So that's the last little bit of that slide. And I'll just finish up with some pictures on one more slide. And this is kind of what we're trying to suggest. So what we want for any individual animal is that we start to get to the point where our positive experiences outweigh our negative experiences. So on the left of the screen, I've got some animals which may well be on the side of having more negative experiences than positive. So for example, the bear there has got quite a barren environment, so it's probably not able to express its whole repertoire of natural behaviours. The pigs there are huddling together. They are probably they're probably cold, so they're suffering from a suboptimal thermal environment. The cattle in the feedlot, they're probably too hot. They're out in the sun and they've got no access to shade. They've got a reduced range size, and the birds in the top picture are not behaving as we would want them to do. They're picking on another bird and pecking the feathers of that bird, which is an abnormal behaviour that sometimes poultry produce. So we want to tilt the welfare the other way, to give animals opportunities to do natural-ish behaviours. So obviously the otter there it wouldn't naturally go ferreting around in a human-made ball of food, but it's giving it something interesting to do, and it's giving it the opportunity to use its kind of mental capacity to solve puzzles and get the food out. And I don't know about you, I may be being anthropomorphic here, but I think the cow looks like it's kind of enjoying having a scratch there. So that's kind of a flavour of what goes on with animal welfare, and underpinning that is a lot of very careful, thought through science to support all of that, and to give us the evidence to be able to go to policymakers, to farmers, to zoos, to other people and say, actually, we've been thinking about it and we've been looking at these animals and we think they now need this. We didn't understand it fully before, but now we do. So I think we should change policy. I think we should implement this. And that's what has happened over the last sort of 10, 20 years. And with people like you in the industry will continue to happen.
Thanks, Zoe. I assume that is all you were going to say on the subject of animal welfare for now. Hopefully everyone's found that really interesting. And we're next going to move on to hear from Caroline, who is going to talk to you about a completely different topic, but one that is equally important. And if you just remember back to what Zoe shared a minute ago, talking about the different domains that contribute to welfare, then freedom from hunger and thirst is a really important one, but actually considering the nutrition of an animal and its dietary needs, you know, in as scientific and careful a way as we possibly can to ensure that we're meeting those needs is really important. So Caroline's now going to talk to us a little bit about animal nutrition, particularly about the value of animal feeds and how we can assess those and then begin to sort of formulate an appropriate diet for an animal. So over to you, Caroline.
Thank you, Rachel, and yeah, good evening, all of you, and thank you very much for joining. So yeah, one thing that we can do, particularly with the animals that we manage, the thing that we generally have control over is what it is that we're feeding them. And it's an important aspect of animal and bioveterinary science is to understand what the animal needs in terms of its diet and how we can supply that in their feed, how we can supply them with the nutrients that they need in a form that they want, possibly, as Zoe was showing earlier, in some kind of puzzle to feed it. But once they've got that food into their system, what value is it? What can we do to assess the feed to be able to determine not only what it potentially provides the animal, but what the animal will actually get from it? So whether it be dogs with pellets that you scatter across the floor or meal that you feed to your pigs, is what you're giving them the nutrients that they need. We move to the next slide. So there's some basic rules when we're feeding animals. The first thing is that the feed that we are offering, particularly when you're talking about horses or farm animals, but also the whole pet food industry, the feeds that we are wanting to use and the feeds which we do use have to be ones which we can grow and produce in sufficiently large quantities to actually be available for the animal. So the first thing is that you could identify a feed which is absolutely perfect, that will give the animal everything that it needs. The trouble is we can only grow about 6 grams of it a year. So first off, is there enough of it? Is it available? And then, having got this marvellous feed, which on paper is wonderful, if the animals turn their noses up at it and refuse to eat it, again, doesn't get as much further forward. So the feed must be palatable. Those cats appear to be enjoying that feed and they are eating it. So first it's got to be available, then it's got to be eaten, and then having been eaten, it must not harm the animal. So chocolate, that's quite available, certainly palatable. My dog will, given a free vote, consume quite a bit of chocolate, except that it's bad for it. So it mustn't have poisons or toxins in it. Feed that has been spoiled, that's gone mouldy, again, not a particularly good choice for your animal, and an absence of anti-nutritive factors. So if we can find these feeds which are available, which the animal will eat, which won't harm the animal, the next thing is how much of what we give the animal will they actually digest and absorb. So for example, giant pandas will eat about 10% of their body weight a day in bamboo. That's what they were evolved to eat. And they will defecate about 9% of their body weight in undigested bamboo. So how much of the stuff that we're feeding is actually staying in the animal? Next slide, please. And what's wanting to talk a bit about today was how it is that you measure and you assess the digestibility of the feed. But start off with a quick quiz.
Which quiz is it? Sorry.
So this is
with the feed.
Energy content of different
Energy content.
feeds. Okay, so just thinking intuitively, out of straw or oats or cardboard, which of those do you think has got the highest energy content, or do you think they're actually all about the same?
If everyone could vote, please. We'll give you 20 more seconds. We're just waiting for a couple more people. Okay, everyone voted now. So 80% voted for oats and 20% voted for straw.
Okay. And you're quite right that if you feed it to most animals, you will certainly get more, the animal will get more energy out of oats than out of straw. and none of you voted for cardboard because there's not many animals that you would feed cardboard to. In terms of the actual energy content though, if you were just to take that, your straw or your oats or your cardboard, and you burned them, you would get about the same amount of energy out of all of them. So when we're assessing, when we're evaluating a feed, we can measure, you know, how much energy it's got or how much protein it's got. And I think the next question asks a similar thing, but on protein rather than energy, which is, if you think about protein content, if you were going to feed an animal leather, fish meal or soybean meal, which of those has got the most protein in it? Or are they all about the same?
Giving you 15 more seconds. Just waiting for a couple more people. I've got all the results. So 80% voted for fish meal and 20 voted for soybean.
Okay. And again, you're quite right. In terms of the amount of protein you would get from that an animal would get, would be more from fish meal than from soya. But if you just took them and took those feeds in the lab and just measured how much protein there was, or with the straw and the oats and the cardboard, how much energy there was in them, they're actually all about the same, because the difference is how digestible, how much of your leather would go just straight through you as opposed to getting digested and absorbed. So what we need is not just a measure of what the nutrients, what's the good that's in the feed, but how much of that feed is available. So just one more quick question on which ones you think might be the most digestible. So if you think of fresh grass just grown in the springs, with just getting the warm bit of weather that you get when you're about to cut the grass for the first time, if you were to eat that, if you were a grazing animal, would you get more, would that be more digestible than wheat or potatoes, or might it depend on what's eating it?
So everyone has voted, and that's 100% on it depends.
It does indeed. Well done. Yes, it does. It depends how you've actually prepared the feed. So raw potatoes, not actually very digestible, but for cows and sheep, actually you'd want to feed them raw, because if you cook them, then they are digested too fast for them. But if you're feeding it to pigs or to poultry, then you would need, or to humans if it comes to that, you do need to cook the potatoes to break up the starch and to make it digestible. Spring grass, highly digestible to grazing animals like horses and sheep and rabbits and llamas and things, quite, but not really terribly digestible to species like humans that weren't really evolved to be able to digest feeds. I mean, there's not a lot of fibre in spring grass, but there's certainly more than you would get in your potatoes. So yeah, it does depend. It depends how you prepare the feed, how you treat the feed before you give it to the animal, and it does depend on what animal you're giving it to. Okay, so how might you measure the digestibility of the feed? You've got a horse like this in its stall, confined to a stall, so you are in control of what it is that it's getting to feed. How might you measure how much of what you put in front of the animal stays in the animal as opposed to coming out the back end? It's not always that easy. So with a single horse in the stable, you could weigh everything that you give it. You could collect everything that comes out the back end. And if you dried things down a bit, you could then work out how much of what had been fed had passed through and come out the far end. But if you've got a group of pigs, then you don't actually know how much any one animal has eaten. the one in the middle could have eaten considerably more than the one to the left. And trying to just collect the feces which has come from one of those pigs when they're in a group situation like that can't really be done, and gets even more complicated if it's a group of animals out grazing. You've got very little idea how much any one individual animal has eaten, and it's pretty difficult to tie down any one pile of poo to one particular animal. So how could we do it instead? And this is when we've got a nifty way of using potential markers that are in the feed. So if you've got your feed, and here's the feed, if that feed has got in it, in the bottom left corner, a little indigestible component, then the animal eats it, and ultimately it will pass it out in the feces. And because this component, whatever it is indigestible, then everything that's eaten, that all of that indigestible component, by definition, has got to come out in the feces. So if it's something like a bit of really insoluble mineral that's in the feed, it's not going to be digested and absorbed by the animal. If it constitutes about 5% of the feed, by the time you get to the feces, well, quite a lot of the feed, you hope, has been digested and absorbed and removed. And so your feces, that indigestible bit, has got concentrated in there. And if it's now constitutes 15% of the feces, then you can calculate from that what proportion of the feed has actually been digested and absorbed. And the simplest way would be that if it was 50% of the feed and then it was all of the feces, then about 50% of your feed has been digested. The challenge that you might think on as to what you do is to how you actually get a representative sample of feces, particularly if it's a grazing animal, and how you make sure that you get a representative sample of what the animal actually ate. Again, more relatively straightforward when you've got a nice compound pelleted feed that you're giving to the animal and that's all it's eating. More of a challenge when they are out grazing and selecting what they eat. But that is basically what you do when you're trying to assess how available a feed is and just what the nutritive value of that feed is. Thank you. So to assess the value of the feed, what you first need to work out is whether there's a sustainable supply of it, and are we going to be destroying the planet in providing a particular feed that we want for the animal. So is there a sustainable supply of it? Will the animal eat it? Will it harm the animal? And then if the feed passes on all of those, what is its composition? Will it meet the animal's needs? And those needs vary depending on what the species of the animal is and what its stage of growth is as to whether or not it's actively growing, whether it's pregnant, or whether it's producing lots of eggs or milk. And having worked out what its nutrient composition is, will the animal actually be able to get those nutrients? What is its digestibility? And the way to assess its digestibility is to use a neat technique like the one that we've just gone through. Thank you.
Okay, thanks, Caroline. Hopefully you found that interesting. We'll have a chance in a minute for questions for Zoe or Caroline about any of the science they've talked about, but also any general questions as well about the course and studying at Reading. Just a couple of additional things I wanted to talk to you about before we finish up. So this slide just shows some of the different opportunities we have at Reading if you come and do the Bioveterinary Sciences course. So first of all, you wouldn't really meet a student studying at Reading who doesn't say one of the reasons they chose to come here was because of our beautiful green campus. And we're not exaggerating when we say it's really, really lovely. It's very big, it's very green. It's a parkland style campus with a lake in the middle with geese and ducks and goodness knows what. And we've got a woodland and a garden. So it's a really lovely environment to study for a start. So it's a good place to start out if you're looking for that kind of campus feel. We've also already mentioned that we have university farms, which are very relevant to this course. So we have the farm at Cedar, which I said has multiple different animal species, and we use that very actively in our teaching. So students on the course get taken to the farm quite frequently through the course for different things, for different research projects, to learn different skills, particularly as Zoe was talking about, thinking about animal welfare assessment skills. You might get involved in doing some nutritional projects, such as the one that Caroline has just talked about. So the farms are a good asset to the course. We also have laboratories on campus as well. So the Bioveterinary Sciences course does allow you to learn some lab skills. And that photo there on the right-hand side is literally hot off the press, taken 2 weeks ago. That is a group of our department students in the lab doing a practical with the microscopes, learning some microbiology techniques and how to look at different bacteria with the microscopes. So the labs are a good asset as well. We've mentioned a range, the range of species that you might be interested in if you're interested in bioveterinary sciences. And obviously we have our own farm animals for access. But we take you on field trips as well. So there's a program of field trips embedded through the course, for example, to zoos, to veterinary pharmaceutical labs, veterinary practices, equine, stables, racing yards, that kind of thing. So we try and show you the full breadth of the animal and bioveterinary sciences industry as well. And then I mentioned at the beginning as well, there are placement opportunities in the course. There's the placement year, which is optional, and you can choose whether you want to do that once you've arrived, actually. So you could apply for the placement course, but you can also apply for the 3-year course and transfer onto the placement course when you're here. There's also study abroad opportunities as well if you choose to study at Reading. So students can go and do a part year studying abroad or a full year studying abroad in one of our partner institutions overseas, where they teach similar courses in English, crucially. So you don't need to know another language to go and be able to benefit from study abroad opportunities. Oh, was I muted through the whole of that, or have I just, no, okay, good. My thing just popped up and says you're muted. I thought, gosh, I hope I haven't spoken that whole slide on mute. I think one of you would have said. Not sure what happened there. So the final bit for me is just thinking about careers then for bioveterinary scientists. So there are various different things you could go into if you chose to do a bioveterinary sciences degree. Lots of graduates from these degrees go into scientific and technical roles in a whole range of companies across the animal and bioveterinary and veterinary industries. So, for example, pharmaceutical companies, bioveterinary labs, veterinary diagnostic labs, that kind of thing, farm, companion and zoo, animal nutrition, and the feed industry that feeds into all of those areas. Some perhaps go and develop a career in animal behaviour. Some pursue a research and development career, and some end up in consultancy type roles. There are also lots of roles in education that you can go into with this type of degree. So some may go on to be lecturers at further education colleges, or they might take a PGCE and become a teacher, biology teacher, for example. And some students are also interested in science communications. They go and pursue those kind of roles. There are also roles in the charitable sector, such as scientific advisors and officers in animal welfare organisations like the RSPCA, Blue Cross, etc. A proportion of students are interested in ultimately becoming a vet. And whilst the bioveterinary sciences degree doesn't qualify you to practice as a vet, it is a useful stepping stone to then go on and apply to do veterinary medicine or science as a follow-on degree after you've completed your bioveterinary course. And some of our recent graduates from the department have successfully got places on veterinary medicine courses at the Royal Veterinary College, University of Surrey, Liverpool, and I think there may even be one at Bristol as well at the moment. Some students also go on and do MSCs, so further their education. For example, we've had students do veterinary epidemiology, animal nutrition, animal physiotherapy and various other master's courses that are provide a further extension of scientific training. And some who are really interested in research particularly might go on to do a PhD in something related to animals, the veterinary field or biological sciences. So I hope that's a useful overview of a flavour of what the course is about, but also about some of the science that is underlying that might get you motivated to want to study a course like this. So I think it's time for questions for any of us. You can ask us anything, so feel free if you've got any questions about any of the science that Zoe or Caroline talked about, to pop those in the chat for them, or if you've got any broader questions about university, about studying this course in particular, any opportunities.
We had some questions come in earlier. One of them has already been answered about the career path, so that was really useful. One of the questions is, how does the course prepare students for climate resilient agriculture, which is probably not as relevant for Biovet, but does the Biovet course consider climate and kind of how?
Yes, so depending on, the course has a number of compulsory modules, but it also has optional modules as well. We haven't talked specifically about the course structure in this talk, so we didn't quite have time, but there are two different ways. Students can use their optional modules and select agriculture-based modules, so they can do our livestock production modules, which do talk quite a lot about sustainability of livestock production in our ever-changing world. So that's one key area where that learning comes through. There's also access to university-wide modules on climate science and climate change and sustainability as well, which students can use through with their optional choices. But we do consider sustainability throughout the whole course. In fact, embedded across multiple different modules, there's always that consideration of sustainability. And Caroline just mentioned in her talk about animal feed, you could have the perfect animal feed, but if it's completely unsustainable to produce, then that's a problem. So, we consider those kind of challenges, particularly around, protein provision, because growing protein sources is really, land and resource intensive. So we might consider that. I don't know if there's anything you want to add, Caroline?
No, I mean, yeah, that's it. I mean, in terms of our research for years, we have been trying to wean the industry away from relying on imported soybean meal. Really good protein source, plenty of it, but plenty of it at a cost. And so, yeah, yes, the trying to make livestock production in particular more sustainable is a key driver to the research that we do at the university, and that feeds through into our teaching in the programme.
Yeah, I'll just add that, yeah, we're the research team do a lot of work on things like reducing methane emissions from cattle. Some of that's feed driven, some of that's based on other factors. We work closely with colleagues in the Environmental Sciences department as well, and from an animal behaviour perspective, I'm currently looking at resilience to climate change in terms of heat events for our grazing livestock and our animals indoors as well. So we've got a situation where we're trying to kind of now anticipate the impacts of climate change and whether or not our livestock systems will be suitable for housing our cows, or whether they're going to get heat stress and things like that.
Thank you. One of the questions is, what are the entry requirements for the course?
I have a slide on that, because I guessed that might be a question. So I'll just put that slide on so that it comes through in the recording. So if you don't get the detail, you can look at it later. But for the Bioveterinary Sciences and Bioveterinary Sciences Replacement Year programme, if you're a UK or even an overseas student doing an A-level qualification, we typically look for 3 Bs, including in biology and one other science, but that other science can be from a whole range of things that are listed there. We very much welcome students who are doing a BTEC pathway in a relevant subject area such as animal management or science or applied science, because they have the requisite science modules in them to kind of meet that biology plus one other science requirement. And we typically look for DDM, distinction merit, that area. If you're doing a City and Guilds level 3 full diploma, again in a relevant science, we'd look for a distinction. International baccalaureate would be 30 points, including at least a level 5 in a higher level biology and another science. And then if you're perhaps looking at the foundation option, the requirements are there as well, so they are slightly lower. So I hope that's helpful. International students, very welcome as well. Haven't listed all the possible entry requirements for international students because it depends on the qualification in the country of study, but our admissions team would be able to advise on any particular qualification or combination of qualifications you're taking in case you're unsure. But we certainly do accept overseas qualifications, and we assess those on an individual basis as the applications come in.
Thank you, Rachel. Another question is, you've mentioned a lot of different career paths, and the question is, what is the demand for those roles? So I guess how likely is it that you finish the degree and then you are employable, basically? How employable would our students be?
Would you like me to answer that,
Yeah.
Caroline, or would you like to have a go? Or,
Obviously,
yeah.
it depends which sector of the industry you go in for. The animal feed industry certainly is always looking for graduates, and our students, I can't remember what the latest is, but there is a high, it is a very high percentage are in graduate level jobs within 6 months of graduating, or further training and higher degree.
Thank you. We have a couple more questions, which will probably take us right up to 5 o'clock if everyone's happy to stay on. So one of the questions is, what sort of placements do students get to do during their placement year?
Well, lots of different options there. I'm just going to try and think off the top of my head where students in recent years have been. So we've had students that have gone and done a placement in zoos, so been a apprentice zookeeper for a year, which is really interesting, quite hands-on. We have students who go and work in some biotech companies where they learn more about vaccine development, product development, that kind of thing. We have had students who've gone and worked for the large animal nutrition companies, designing components for animal feeds, thinking about micronutrients and feed additives and all those kind of things. So really, we encourage students to think long and hard about what it is they are most passionate about, and then set about pursuing a placement in that area. And we support students a lot in terms of preparing for that. So offering support on building a good CV, writing a good application, preparing for interviews, and assessment centres or any other steps that might need to be taken to secure a placement year within any chosen area that the student's interested in.
Thank you. One final question, which, does our university offer a degree that instantly qualifies our students as vets?
Very easy answer to that one is no, it doesn't. We don't teach veterinary science or veterinary medicine, which are the two key courses in the UK, which are accredited by the Royal College of Veterinary Surgeons. I'm afraid Reading doesn't have a veterinary school, but we do have a very long history of teaching animal sciences and researching animal science, and we're, as I say, really well placed to help train people for different allied jobs that support the veterinary industry and the animal industry more broadly. And as I said earlier, if students are interested in doing veterinary science or medicine as a postgraduate, as a second degree, we're also very happy to support those students. So, for example, writing references for them, assisting them with their UCAS applications for those, for going on to those courses, etc.
And I said one last question, but one more question just came in. Does this course accept access to HE students? Which I think is a really good question.
Yes, and I that was included on the entry requirement slide, but absolutely yes, providing that access course is in relevant science subject, so that you broadly meet the science requirements. So we'd look for that access course to have had a decent amount of biology teaching in it and another science element of some kind. But absolutely yes, we have students on the course right now who've done access to HE, so no problem at all.
Perfect. Thank you so much, everyone. Thank you to our colleagues for hosting. Thank you to attendees for asking the questions. And if anyone has any further questions, please email Rachel. Her email is on the screen, and we will be circulating. So in case if you missed anything, you can rewatch back or share with your friends who might be interested as well. Have a good evening, everyone.
Thank you.
Thanks everyone for joining.
Thank you.
Thank you. Bye.
Bye.